Downcasting and runtime type information. Since you lose the specific type information via an upcast, moving up the inheritance hierarchy, it makes sense that to retrieve the type information, that is, to move back down the inheritance hierarchy, you use a downcast. However, an upcast is always safe because the base class cannot have a bigger interface than the derived class. Therefore, every message you send through the base class interface is guaranteed to be accepted. But with a downcast, you don't really know that a shape, for example, is actually a circle. It could instead be a triangle or square or some other type. To solve this problem, there must be some way to guarantee that a downcast is correct, so that you won't accidentally cast to the wrong type and then send a message that the object can't accept. This would be quite unsafe. In some languages, like C++, you must perform a special operation in order to get a type-safe downcast, but in Java, every cast is checked. So even though it looks like you're just performing an ordinary parenthesized cast, at runtime this cast is checked to ensure that it is in fact the type you think it is. If it isn't, you get a class cast exception. This act of checking types at runtime is called runtime type identification, RTTI. The following example demonstrates the behavior of RTTI. As in the previous diagram, more useful extends the interface of useful. But since it's inherited, it can also be upcast to a useful. You can see this happening in the initialization of the array X in main. Since both objects in the array are of class useful, you can send the f and g methods to both, and if you try to call u, which exists only in more useful, you'll get a compile time error message. If you want to access the extended interface of a more useful object, you can try to downcast. If it's the correct type, it will be successful. Otherwise, you'll get a class cast exception. You don't need to write any special code for this exception, since it indicates a programmer error that could happen anywhere in a program. The throws exception comment tag tells this book's build system to expect this program to throw an exception when it executes. There's more to RTTI than a simple cast. For example, there's a way to see what type you're dealing with before you try to downcast it. All of the type information chapter is devoted to the study of different aspects of Java runtime type identification. Exercise 17.2, using the cycle hierarchy from Exercise 1, add a balance method to unicycle and bicycle, but not to tricycle. Create instances of all three types and upcast them to an array of cycle. Try to call balance on each element of the array and observe the results. Downcast and call balance, and observe what happens.